I'm going to work a problem that involves work done, and more specifically involves the relationship between work done and force, and the relationship between work done and kinetic energy, change in kinetic energy. So in this problem, I'm imagining I've done this, pushing my car. I'm pushing my car from rest to some speed. And I'm doing a certain amount of work when I push the car, 5,000 joules of work, and my car has a certain mass, inertia, 2,500 kilograms of mass. And I push the car to the final speed over a distance that's 25 meters. And the question asks me to, I neglect friction, or don't worry about friction forces, find the force that I'm exerting and find the final speed of the car. Now, answering these two questions involves thinking about the work I did, the 5,000 joules of work I did, and how that's related to the force, and how that's related to the change in kinetic energy. So that's how we're going to go about solving this problem. I'm going to, of course, start with a sketch of the problem, a little drawing of the problem. Helps me clear my head, helps me think about what's going on in detail, helps me think about what I know, what I don't know. Here's the car, and I'm exerting a force on the car. I'll just call it F, towards the right. And because I exert a force on the car, that car, which was initially at rest, I'll call that initial speed V0, is a non-zero speed after the push. I'll call that speed V. And I'm pushing over some distance. I'll call that X. That's 25 meters. And during this pushing of the car, this doing work on the car, the amount of work that I do is 5,000 joules. So that's the information that we know. So now let me go about answering the two questions. First one is, what is the force? I'm really just going to worry about the size of the force. You know, if I push the car to the right, the force is to the right. The question really is how big or small a force I'm exerting towards the right. And to solve this part of the problem, I'm just going to use that relationship between work done and force. It's this little guy here. W is the work done in joules. F is the force exerted in newtons. X is the distance over which the force is exerted. And cosine theta is an angle. It's the angle between the direction of the force and the direction of the displacement. So we can take that equation, we can rearrange it. And we can rearrange it for the unknown force, in this case, in terms of the known work that's done and distance pushed. Now, in this particular case, right, I'm pushing towards the right. The car is moving towards the right. And so that cosine theta, which is the angle between the direction of the force and the direction of the motion, it's going to be the cosine of 0 degrees. It's going to be just 1. So we don't have to worry about the cosine. All we have to do, in fact, to figure out the force in this simple situation is take the 5,000 joules of work that I did and divide those joules by the distance that I pushed the car. That's 25 meters. Well, this is convenient. 5,000 over 25, I can do that in my head. This is 200 newtons of work done. And so that's the work done based on that relationship between work done and forces. The idea that forces do work, that they transfer energy. Next part of the question, what's the final speed? Well, we can determine the final speed from another relationship for work. It's the relationship between the work done and the change in kinetic energy. And specifically, it's that the change in kinetic energy is equal to the work that you do on the object. And in this case, well, we started with zero kinetic energy because the object was at rest. We end up with finite kinetic energy because the object is in motion. So the change in kinetic energy is just 1/2 mv squared. 1/2 times the mass of the car times the final speed of the car. So again, we're in a situation where we can figure the quantity that we're interested in, the final speed, from the quantity here that we know, the work that I did in pushing the car. All we got to do is rearrange this equation. So I'm gonna multiply the work done by 2, divide it by m, take the square root, and that will be equal to the speed. And then I just got to fill in the work done. That's 5,000 joules. The distance, sorry, the mass of the car, that's 2,500 kilograms. And I think I can calculate this one in my head too, because I've got in the numerator 10,000, 2 times 5,000. In the denominator, I got 2,500. So inside the square root is 4, and the square root of 4, I know that is 2. So that final speed is 2 meters per second. And so that's a short little example of work done, which is transfer of energy. In this case, we knew the work done. We knew the energy transfer. It was 5,000 joules of work transferred from me to the car. And by knowing the work done, we were able to figure out the force I was exerting in transferring that energy. And we were able to figure out the gain in kinetic energy due to that transfer of energy. And so that's the connections between work and forces and energy.